yelling into it, then apologies for whatever I just did to your recording. Does anybody know what matrix is? Did anybody make it to the lightning talk yesterday or otherwise speak? Okay, a handful of people, so we might need to do some Matrix 101 rather than jumping straight into IoT specific stuff. But basically, what's the problem with IoT from our side? Well, this is, I'm going to try to minimize the slides, but typical past couple of devices talk to one another, nothing really talking to the cloud. Today, I'm sure that you've got, I haven't been in the room yet today, obviously, but I guess we've been talking about fragmentation and silos and the fact that you end up with a bunch of different vendors who want to go and take your data and chuck it into their particular cloud, and the devices are locked to that cloud, and perhaps the apps for manipulating them are also locked to that vendor service. And it sucks because you don't own your data at all. Even the open systems, so if you're using a nice open protocol like MQTT or CoAP or something like that between the devices and the backend system, the chances are that the data is going to be locked into your IBM cloud or your, I don't know, Garmin or Fitbit or whoever it might happen to be. So Matrix is all about data liberation, and that's basically going over what I was saying then, that it's stored in silos, you're locked with apps and the vendors, so you're basically locked into a given vendor, things don't interoperate, and you've got horrible fragmentation because your devices from different vendors aren't going to play nice. So Matrix's data liberation efforts to go and provide a open source persistent database for decentralized messaging, basically, or decentralized data of any kind. So we're a very new project, which is why you probably haven't heard of us. We started in September, we went into beta in December, so we're in pretty early beta right now. We're a non-profit, and what it is a bunch of HTTP APIs for decentralized persistent messaging. So rather than inventing yet another REST API where you put some JSON to a service to put some data up to the cloud, instead we provide a very simple client-server API, if you want to talk HTTP, that allows you to put JSON out there. It's all open source, and we've both opened up the spec as an open standard, and we've got Apache license reference implementations everywhere. So our mantra is basically an open, decentralized, persistent, eventually consistent, cryptographically secure messaging database with a JSON over HTTP API. So if you think of what would happen if something like Cassandra had babies with XMPP, then you end up with something a bit like Matrix. So anybody can go and spin up their own node, their own server, and start replicating state for a room, as we call it. It was originally written for instant messaging, but it applies really nicely for IoT because in the end it's any kind of JSON that you can publish in the context of a room. And your server will start replicating the state of any other room that it's participating in with any other servers. So there is no single point of control and no single point of failure over where that data is stored. So we have the ability to break down the walls between the vendor silos for IoT. We can also go and bridge the gaps between all the different messaging bubbles out there, like I know IRC networks, XMPP, commercial proprietary things like WhatsApp too on the non-IoT side of things. So key characteristics, it's aggressively open. So it's obviously an open standard, an open source, open project. Anybody very welcome to give us some pull requests on GitHub. And we're doing completely open federation, so anybody can spin up a server. Message history is the first-class citizen here. This isn't a message passing protocol like XMPP. It's very much a state synchronization protocol. Group communication is where it's at, which is very useful for IoT because obviously you've got lots of different devices wanting to submit data into a similar space. So there isn't any point-to-point communication here. You're always going and updating a group communication sort of room. We're using strong crypto between the servers to prevent spoofing. For the chat use case, we're identity agnostic, and we will be supporting axolotl end-to-end encryption real soon now, but it hasn't landed yet. So, enough talking. Slides. Apologies for the slides. Let's do a demo. So, let me wait for my ancient Mac to do its thing. Here is what you get with an evil photo of me. Apologies, I'm using my test user, so you've got the evil one who wears a suit. Going and logging into our web interface on a Matrix server. Now, this is just a test user, but if we go into a channel like this, and just is this going to make sense? It probably is. So this is hash matrix on matrix.org, and it's showing a whole bunch of chat content. Ignore this graph here. This is for the IoT bit of it in a minute. But here you've got a whole bunch of history of people chatting away from FOSDEM. You can see myself and a bunch of other folks, and a whole bunch of users in here. If we go and look at somebody like Evil Matthew, then I've got Matthew Test on matrix.org as a username, whereas find somebody on a different server. Like this guy here is running his own server, jki.re. And all of the state of this room, so all of the JSON, and if we double click on anything here, it pulls up the underlying JSON. Apologies if you can't see this, let me zoom in a bit. So it's freeform JSON. Here it's just a text message with a body and the room ID, and the type is an m.room.message, which is some kind of message within that room. So at the moment, you're thinking, hey, this just looks like IRC with a bit of XMPP and all the rest of it. So this is potentially more interesting. So I've got an invite here from a new room, which is hopefully, is this going to work, Leo?
Well, I'm going to press the button. Do you want me to press it?
Okay, well, let me explain what we've got set up here. So we've got a test user here, Leo's testing user. Leo's squatting in the corner down here. He's got an Android phone there, which is hooked up via Bluetooth to a car. But it's a special magical car that you can't see because we can't fit one in here. We were actually trying to use a real car, a Volkswagen Passat, somewhere in Rennes in France, but it turns out that the telemetry port that we're using on it has some strange characteristic, which means that we can't get the data out. So we're going to have a really cool remote demo where we go and get live telemetry out of a car in France, stream it into Matrix in real time, and look at the graph update. But as I said, the ODB2 port, which all cars since 1996 expose, is one of the least standardized things other than the physical connector, and we failed to get the data out. So we're running a car simulator on the laptop. It's talking Bluetooth to the phone. The phone is running a Matrix client, which is submitting bunches of JSON, hopefully any minute now, into the room, and then we're consuming it in the AngularJS web interface here. So there we go, it's a miracle. We've actually got messages coming in here, and to make it more visual, what we've done is to give them text bodies as well as the JSON metadata. So we're visualizing them here with D3, just drawing the graph in real time as they come in. I think we're submitting every second by the looks of it. And if we go and actually double click on one of these, you can see that, okay, it's a message for the room, and we've got an English body for human readability, but because it's arbitrary JSON, we've just gone and chucked some random key value pairs in. So we've got a type of this message, which is a Java-style namespace, so it's uk.org.leonerd.engine data, Leo's personal domain, inverted with the type, and then we've got some random telemetry that should be coming off a real car. If your car did have a temperature of 211 degrees centigrade, you would probably worry, like, you know, although I guess 5,000 RPM isn't that bad. And I think we were measuring the load on the battery or something too there. So the point here is that we're submitting completely random data from a random lightweight device somewhere in the world into this data fabric. And in this particular instance, I think we're both on the same server. Yeah, we're both using the matrix.org server. But Leo could be running his own Matrix server on his own domain. In fact, that would have been a better demo, given you've got one. Oh well. And we would then be federating that data over, synchronizing it in real time between the two servers. So even if the matrix.org server goes down, the data would still exist on Leo's one. We could lose all of that data, throw it away, and then synchronize it back in from Leo's side. So literally nobody owns the data. Likewise, Leo could go down, lose all of his data, and we could synchronize it back in from matrix.org. Everything's signed so with a blockchain-style algorithm that I'll talk about in a minute to make sure that nobody tampers with history, because you've got a big problem if some random person federates into this room and suddenly starts submitting history that never really happened. But that's basically the architecture that we have going on here. So we hope the Matrix will be this very simple generic HTTP messaging fabric, which anybody who wants to pub sub some data persistently can just go and chuck it into. So rather than every random HTTP API on every cheap temperature sensor inventing yet another REST interface, there's just a really standard way of doing it. So you probably want to see what the actual API looks like. Let's go and not look at the boring slides, but actually look at the inspector here to see what's going on the network. Now, I should emphasize that we're not proposing Matrix as a device protocol necessarily. It's obviously convenient if you've already got HTTP in there that you might as well use the standard HTTP API for submitting that data. But if you want to talk MQTT or MQTT-SN or CoAP or something a lot more efficient, then that's fine. I mean, just needs to bridge it at some level into the HTTP layer for Matrix, and that you could run your own transport on the server to support doing that, or you could have a gateway like a CoAP to HTTP gateway. The value that Matrix is bringing is instead the federation, the synchronization, the crypto between the servers, rather than trying to be a silver bullet for the device-to-server interface. That said, you still need to get data in and out of it somehow, so we might as well look at the HTTP. And you can see here, or at least I hope you can. Oh, there we go. Wow, you can zoom on the inspector. That's cool. There are a bunch of long-lived polls here, each one taking 30 seconds, or in fact taking a second, because it's a long-lived GET request just polling for data. You're probably thinking, ugh, long-lived polling, that's a bit 1998. We've deliberately implemented the simplest possible baseline HTTP API imaginable, so that if you are running it on a constrained device and you don't have WebSockets, you can just do a GET request. I know it sounds horrific to talk about HTTP on a constrained device, but either way, wanted to keep it as simple as possible. So if you can do WebSockets or CoAP, but that's an optional transport for you to have between your particular clients and the server. If we look at what happens when I actually send a message in here, sorry, I'm a bit constrained myself on screen real estate. So I'm just going to say, you can stop now, Leo. And the instant message has gone through there. Now hopefully, meanwhile, on the inspector, we can find that request that happened then. And so we're looking for a put, and hey, there's a put. Hopefully this is the actual message rather than a typing notification. And you can see the URL here just about is going to matrix.org_matrix client API v1 rooms, this horrible room ID, which is the internal identifier of this room, and then we're sending a message of type mroom message. So it's not quite REST, well it is REST, but it's not a typical REST-ish pattern, but we've gone for pragmatism rather than being rabidly pure REST. The actual put here, hopefully this is the message. Yes, brilliant. So you can see that we're putting through an m.text body, you can stop now, and the response we got back is the ID of the event that's being created. Meanwhile, on the next time our long-lived poll does something, I think that's probably the typing notification. Yep, and then we get a local echo, or we get a remote echo coming back from the server. So this is our events request, which is going and polling our event stream, and we get a bunch of chunks of data, and they have an age, they've got the content of the JSON which we put up there, we've got the event ID, we've now got a timestamp from the origin server where it entered Matrix. Sorry. We've got the room ID, ugly thing again, we've got the message type and the user ID, and it's basically precisely the same data that we would see if we went and double-clicked on the message there. Make sense? Any questions?
So we say that every room is a pub sub topic?
Yep, precisely. In MQTT terms or in a pub subs, you could think of it as a topic, but critically it's persistent by its very nature. So unlike MQTT, where your broker can persist things and it has a history, instead the history is baked in as the fundamental building block for all of this. So another, just whilst we're at it, another thing that you can use this for is just arbitrary signaling of any flavor. So let me go and go back, oh, horrible, go back into Matrix on matrix.org, and this chap is in building H at the moment, and so if I start a new conversation with him, and I hope that he's awake, Hello. Here we can see invitation semantics going on, that I've invited a user, but it could equally well be a device to go and join a new topic, a new room. Oh, and there he is. So he's gone and joined. In the Angular UI here, if I hit one of the camera or microphone buttons, I can fire up WebRTC, and if we're on the right network, which we are, because we embarrassingly aren't talking IPv6 on our relay servers. Then you've got Advar there. Hi Advar, we actually got audio this time. So you can see that's a WebRTC call that's been set up for it. So, not strictly relevant for IoT, but you can imagine for a security camera style context, having a very, very simple VoIP setup API over HTTP is actually kind of useful. If anyone here has hacked on WebRTC, you'll be quite frustrated, I imagine, by having to embed a SIP client in your browser or making up yet another HTTP API, whereas of course, like the XKCD cartoon says, ours is the one true HTTP API. Or you're talking Jingle or something like that. Whereas here, if we actually look at what I did, again, I just put a JSON blob into it. This one is of type mCallInvite rather than mRoomMessage. And there's this horrible thing here, which is the session description protocol that is taken straight out of WebRTC. So all it's doing is talking to the RTC peer connection API in WebRTC, grabbing that blob, putting it in JSON. So it's one hit to set up the call. For the guy to respond, he just puts the response from his WebRTC. So that's one hit, and you're in. That's it. So no SIP, no Jingle, just really, really simple standard JSON messaging. So that gives you a vague idea of the demo. I guess I should see what else I have here. Architecturally speaking, let's wait for useless PowerPoint to do its thing. Come on, you can do it. Yay. Architecturally, it's a typical federation of servers with clients hanging off them. Might as well be email or XMPP or SIP or anything like that. The slightly interesting things are that at the moment, we have identity for the kind of human identity problem handled as a separate cluster of servers. That's probably going to get decentralized too, but at the moment it's a logical single point like DNS root servers. And we also have application services any day now. So we've finished writing the spec for this, but it's basically defining bots which can manipulate the data in the fabric with superpowers. It's like the hybrid between an IRC bot and IRC services, and it lets you start doing arbitrary business logic on the data in the fabric. I'm going to talk about that in a bit. Clients, obviously, well, by default, talk HTTP. It can be as thick or as thin as you like. So the Angular client I was just showing you here was crazy thick. It stores all of the history locally in HTML5, local storage. It has offline operation, blah, blah, blah. Whereas Leo's client there on Java on Android that was submitting the telemetry, yeah, it's a single put, and it's I think the SDK it's using is a couple of thousand lines possibly of Java boilerplate to go and talk to the API itself. Identity servers, talked about those. Application services, talked about those. So I'm going to show you another bit of visualization to try to articulate more clearly what's going on with the data here. And it's actually on the homepage of matrix.org, so you can follow along if you so desire. And we've got this thing called How It Works. And what we have here are 3 participating servers and 3 clients hanging off them. Here they're humans, but they might as well be devices. And what happens is that if Alice goes and sends a JSON message into the mix, you can see we've actually got, just about see perhaps, we've got the curl, if I could select it, which I can't. You have to believe me that there's a curl there which is posting the JSON to actually go and send this through. And it obviously hits her home server, and the server goes and persists it, and it starts building it into a graph there of the history of that room. And it signs it with the key pair that Alice has on her server. Well, I guess signs it with her private key. Now, that gets relayed over to the other guys, and they also persist it in their servers. So at this point, everybody's in sync. We've got a consistent view of what's happening in that topic, that room, whatever you might like to call it. The servers validate the message signature before accepting it. They also validate that the identity of alice.com is correct. They also check whether at ACL level you're allowed to do whatever that message was. So we've got a decentralized ACL system built into here, so that if Alice, that user or that device doesn't have permission to post a particular type of message at that point in the room, then you basically have to get people to prove that they have permission to do the things they do. It's kind of cool and one of the most useful bits, because otherwise it would be a free-for-all. It's modeled after IRC semantics, basically, but that's kind of good enough. So that message gets relayed out to the other end, and you can see the GET request. On the V2 API for the client-server side, we use /sync, which is a very cool incremental sync API rather than an event stream that I showed you on version 1 just now. Now, say Bob responds, or the device called Bob responds and goes and builds another message into his server graph. And you can see it's gone and created a link here to the previous message. And this is because he's building up a data structure where each message goes and points to the previous one, and is cryptographically signed using a blockchain style thing. So he has a link to the previous message, including its signature, which goes and signs, which is signed in its own right. So you can keep on following back this chain of trust to the beginning of the room to stop people from inserting or manipulating history. But if Charlie also goes and sends one at the same time, you got a race. But hey, it's an eventually consistent database. This is fine, because when Bob's message relays out, all that happens is that we get a bifurcation in the message graph, the conversation history here, effectively. Just like Cassandra or Dynamo would go and split history, effectively. And when Charlie's message propagates as well, everybody is now back in sync. Say, yeah, okay, there was a race between these messages, but that's okay.
Matthew, if you want to have questions, you have 3 minutes for that.
Okay, cool. Well, you get an idea that we're building up an eventually consistent database. Any questions? Yeah, go for it.
Given that this is all cryptographically assigned and there's a bit of overhead in the payload, what is the average latency that you would get if you're trying to achieve near real-time or as real-time as possible?
So at the moment,
Can you repeat the question for the video?
yeah, for sure. So the question was, how performant is it? How bad is our latency, especially given we're doing crypto, and also especially as we persist everything? And the answer is that right now it sucks because it's early days. We haven't done any performance work at all. The reference implementation is in Python and Twisted, which isn't the fastest thing. We're using SQLite for the backing store, which is pretty fast, but not exactly multi-threaded. So we're seeing a couple of 100 milliseconds to go from end to end through federation, which could be so much better. But it would be the crypto isn't the bottleneck at all. We're using elliptic curve stuff to sign it. It's very, very lightweight. It's more the persistence, and if you're talking HTTP1, the fact you're probably setting up a new connection for each hop that's taking the time. But that's definitely optimizable. It's not super fast, but it should be good enough.
We actually have a second question. Cryptographically signed, does that mean it's in an HMAC or is it actually fully encrypted message?
So at the moment, we're not actually encrypting it at all. Instead, we're signing it, and so I should have shown you the JSON of one of the federated messages, but basically you got a bunch of ED, whatever the elliptic curve signatures on the JSON. Oh, and I should repeat your question, of course, which was, are we using HMAC? Are we actually encrypting the message, or are we just signing it? And over federation, yep, it's just signed.
We are planning end-to-end encryption.
Completely separately, yeah, between the clients, we're going to have end-to-end too, but that's a bit like OTR, or we'll be using Axolotl, which is Moxie Marlinsberg's crazy scheme for asynchronous key ratcheting over group communication. But that's separate from the trust domain that exists between the federated servers. Any other questions?
How does a client authenticate to a server?
So the client auths with the server using an access token for now, which is just a get parameter, so not exactly super secure. And the question was, how does the client authenticate with the server? And how you actually get that access token is a pluggable authentication scheme, a bit like OAuth. OAuth is one of the implementations of it, but you could also do a two-factor auth to go and like identify a phone number and validate a user that way. It's basically an extensible framework between the client and server to manage it.
Okay, sorry, we have finished. Any more questions? You can take them outside. Big round of applause and thanks to Matthew for this.
No, sorry.